And so we're going to have another old friend come to visit, and that's going to be Q. Okay. So let's go back to our calcium carbonate example. Okay, so there's the equation for it, and here's the expression for it. This equation is actually valid for any solution that contains calcium 2+ and carbonate ions, not just one that is saturated. So in other words, it doesn't matter if we're in a saturated solution or if we just have a little bit of this dissolved and no precipitate at the bottom. Okay, so it doesn't just apply to a saturated solution or a solution that's at equilibrium. So let's remind ourselves about Q. So remember, we can calculate Q whether we're at equilibrium or not. Okay, and that applies to these systems as well. So if QSP, okay, is less than KSP, then no precipitate occurs. Okay, so just written just a slightly different way, QSP less than KSP, reaction proceeds in the forward direction. Okay, so in that case, no precipitate, basically we're dissolving. That's the bottom line. We're going in the forward direction and we're dissolving. So if QSP is greater than KSP, then we're going to have precipitate. Okay, so we're going to precipitate some out of solution, written that slightly different way. QSP is greater than KSP. Reaction proceeds in the reverse direction. So in other words, we are precipitating. Okay, and so we're going to get more of that solid precipitate. Also remember, if KSP, and this is just like chapter 13, is equal to QSP, then the system is at equilibrium. Okay, so really make those connections back to chapter 13, because that'll just make this a piece of cake. Okay, so let's just do the last thing and write out Q for our reaction above. And so remember, it's basically just the same thing as KSP, except we're not measuring at equilibrium. Okay, and so there's our expression for KSP. So let's do an example to see if we can predict whether a system will precipitate or not. Okay, so let me write down the problem for you. So the first step in preparation of magnesium metal is the precipitation of magnesium hydroxide from seawater by the addition of lime. So you already know what lime is, and that's just calcium hydroxide. So you've seen this, you've seen that compound. So that's lime. So we're going to add lime, and we're going to inspire that precipitation of magnesium metal. But first we have to find out if when we do that, if we're adding enough to actually cause that precipitate. Okay, so let's look at the equation for magnesium hydroxide dissolving. So again, you should be able to write this out yourself just by being given the compound, and the KSP here is 8.9 times 10 to the negative 12. Okay. All right. And another little piece of information that we need and that we're given, the concentration of magnesium cations in seawater is 0.0537 molar. Okay. So the question is, will magnesium hydroxide precipitate when enough calcium hydroxide is added to give hydroxide ion concentration equal to 0.0010 molar. Okay, so there is our question. All right. So now what we have to do, we have to figure out if under these conditions, if QSP is larger or smaller than KSP, and then we're going to be able to answer the question. So first thing we're going to do is calculate QSP. Okay, so QSP is equal to magnesium 2 plus hydroxide ion concentration to the second power. We're going to plug everything in, 0.0537 and 0.0010, and that's going to be equal to 5.4 times 10 to the negative 8 when we do the math. Okay, so there is the value for KSP. So I'm sorry, QSP. QSP is equal to 5.4 times 10 to the negative 8. So now what we're going to do is look up at our KSP that we were given, which is right here. And we're going to say, is it larger or smaller? And it actually turns out that QSP is, of course, larger than KSP. And so that tells us that the reaction is going to go in the reverse direction. And that means it's going to produce precipitate. Okay, so let's just go ahead and write in these values. That's larger than 8.9 times 10 to the negative 12. Okay, and so the reaction is going to proceed in the reverse direction. Okay, that means it's going to produce precipitate. So it produces precipitate. All right, and it's going to produce precipitate until QSP is equal to KSP, and then the system will be at equilibrium. Okay, so it's going to precipitate out until the concentration of ions dissolved in solution is appropriate for equilibrium. So when it's low enough that that QSP is equal to KSP.